It says express cos of x plus 3 sine x in the form r cos x minus alpha. So you see, they give us the form that they want. Cos of x plus 3 sine x. This needs to be converted to r cos of x minus alpha. They're telling you r should be greater than 0 and that alpha should be acute. All of that is given. You need exact value of r. That's an instruction that often comes in these problems as well. They often ask you for the exact value of r. Okay, so you have to give an exact value. And the value of alpha corrected 2 decimal places. Now, 2 decimal places means exactly 2 decimal places. Whenever such an instruction is given in the question, you have to make sure that you follow that. You can't write 3 decimals here. You can't write 1 decimal. It has to be exactly 2. Okay. Now, what do? We remember the formulas. We know tan alpha equals b over a. And we know that r equals a squared plus b squared. We just input values, right? So the first number is a, that's 1 here, right? The second number is b, this is 3. Just input values. Tan alpha is equal to 3 over 1. Take find tan inverse of this and see what that gives you. Tan inverse of 3. Let's try that. This gives me 71.565. Now we need to be careful. It's 56505, or you can say 565. Yeah, let me just write that 56505. How do you round it off? It's 71.57. All right. You have to write 2 decimal places. So alpha equals this 71.57 degrees. Now, what about r? For that, you just say square root of a square plus b square. That's 1 square plus 3 square. And that's going to be square root of 10. You don't write the decimal value for this. They want an exact value. Now you have to express it in that form. What was that form? R cos into x minus alpha. R cos of x minus alpha. Let's just input values here. R is square root of 10 into cos of x minus 71.57. This is what we wanted. So we just use those 2 formulas and we get the values of alpha and r from this. All right, now this is, once you remember these formulas, this is probably the easiest question in paper 3 now. It's basically just free marks. You just have to remember these formulas. Tan alpha equals b over a and r equals square root of a square plus b square. So in the second part now, you would just have to solve this equation. Because what was the equation originally? The original equation is cos 2 theta plus 3 sine 2 theta. That is equal to 2. You need to solve this equation for theta between 0 degrees and 90 degrees. All right. Okay, sorry. So actually just get rid of this. And the first part, what we have done is we had something of this form. Cos of x plus 3 sine x. We had something of this form. We have converted it to square root of 10 times cos of x minus 71.57. We've converted it to this form. That's what we have done in the first part. Now, in the second part, we are asked to solve this particular equation. Now, you see what you have on the left side is very similar to what you have converted to another form in the first part. The only difference is in place of x here, you now have 2 theta. So in place of x, you have 2 theta. So the first thing you do is you convert this left-hand side to a form like this. And how do you do that? You can replace this thing with square root of 10, right? That's what we have here, into cos of x minus 71.57. But remember, what do you have in place of x here in the equation that you've got? You have 2 theta. So you say this is 2 theta minus 71.57, that equals 2. So essentially, this is the equation that you need to solve now. All right. This is the equation that you need to solve now. Square root of 10 into cos of 2 theta minus 71.57 equals 2. We need to solve this equation now. Now, how do we solve such equations? We've done this in paper 1. Let's quickly review that method. This is the interval that we're given from 0 to 90 degrees. Now, there are multiple ways of thinking about this. One possibility is, and what we do is we say, let's replace this thing, because you see the angle is not theta here, the angle is this whole thing. So whatever is written inside this whole angle, one possibility is that you substitute this with another variable, and that you're going to find this the easier method in most situations. Just substitute this whole thing with another variable. So use any letter for that. Let's say let a equals 2 theta minus 71.57. So use this substitution. Whatever is inside here, this whole angle, replace that with another variable. So this equation would therefore become square root of 10 times cos of a equal to 2. And now you're just solving this equation instead of solving this complicated equation that you had before. All right. So replace this whole thing by another letter. You replace that with a. But remember, when you do that, the interval that you were given was for theta. You have to convert this interval to something in terms of a as well. How do you do that? What you can do is you can say, let's input 0 in this. If you input 0 in place of theta in this, what do you get? What value of a do you get? 2 times 0 minus 71.57. So the value of 0 there corresponds to minus 71.57 here. That's the minimum value of a that you could have in the interval. Then the upper bound here is 90. You put 90 here in place of theta. That gives you 2 times 90, that's 180. 180 minus 71.57, that would be 108.47. Sorry, 43. So this would be the first thing that we do. We use a substitution like this. We replace this whole thing by another letter. And then we have to convert this interval accordingly as well. The interval was for theta. Our angle is not theta now. Our angle is a. So we find the interval for a. Now, once you're done with that, you just solve it like a normal trigonometric equation. So what do you do after this? You say cos of a equals 2 over square root of 10. You could simplify this. You could actually evaluate this 2 over square root of 10. Let's see what that turns out to be. This is 0.6325. Now find the basic angle. How do we use to find basic angle? We say cos alpha equals 0.6325. Find alpha from this. Remember, the angle is in degrees, so your calculator should be in degrees mode. Find the basic angle and see what that turns out to be. Okay, so angle in this case, cos inverse of 0.6325, that is 50.77 degrees. All right, you need more accuracy here because this is not your final answer. So you need to make sure that your final answer is accurate. For that, you need at least 2 decimal places here for the angle in degrees. Now you have the basic angle. You could think of quadrants now. So these are your quadrants. Cos is positive. Where is cos positive? Cos is positive in the first quadrant. or in the fourth quadrant. So you could have your basic angle here, 50.77, or you could have your basic angle here, 50.77. And now you look for angles within that interval that you have in these two quadrants. Let's look at the first quadrant. In the first quadrant, you could have A equal to 50.77. Let's look at the fourth quadrant. If you go all the way here like this would be outside the interval. You see, the interval is only until 108. This angle would be bigger than 108, so we can't go there. However, notice that we also have negative values in the interval, so we also need to check if there are any negative angles which are in the interval. So you could go clockwise here, like this. This angle is minus 50.77 as well, if we go clockwise, and that is within this interval. So another possible value of A here could be minus 50.77. These are the two values of A that you get from this. All right. Now, once you have the values for A, what you can do is you can just put that substitution back. You had assumed this thing initially, A equals 2 theta minus 71.57. Just replace that back and say 2 theta minus 71.57. That is equal to 50.77, or 2 theta minus 71.57 equals minus 50.77. You get these two equations, you find the values of theta from this. From the first equation, you get 50.77 plus 71.57 whole divided by 2, and that will give you some value of theta. And then from the second equation, you get minus 50.77 plus 71.57 whole divided by 2, and that will give you another value of theta. If you calculate the first one, that is going to turn out to be 61.17, and the second one turns out to be minus 50.77 plus 71.57 divided by 2, that is 10.4 degrees. These are the two values of theta that we're getting. 61.17 and 10.4. And notice here, if you adjust this interval correctly, the final answers that you get are automatically going to turn out to be in the interval that they've given in the question for theta, which was between 0 and 90. You automatically get values between 0 and 90 from this. All right, so you won't have to do anything extra for that. You would already get the answers in the interval that's given. All right, so this is how we solve equations like these. All right, this is part 2. So whenever you have the first part in which they ask you to convert something to this form, r cos something, r sin something, you would find yourself doing this in the second part a lot, that you'd have to solve an equation like this. All right, again, so in the first part, it says express this thing, square root of 6 times cos theta plus square root of 10 times sine theta in the form r cos of theta minus alpha. You want to convert it to this form. All right, that's what is given. And they've given some instructions related to that. They've asked us to give value of r greater than 0 and alpha between 0 and 90. So alpha should be acute. Now, how do we do this? Again, we just use the formulas we know. The first number here is going to be a is square root of 6, and the second number is b, that's square root of 10. We just apply our formulas. Tan alpha equals b over a, and r equals square root of a square plus b square. Just input values. Tan alpha equals b, which is square root of 10 over square root of 6. Take tan inverse of this and see what you get. Tan inverse of square root of 10 over square root of 6. Let's see what we get from this. Okay, this turns out to be 52.24 degrees. You're asked to give your answer correct to 2 decimal places. So it should be two decimal places like this, 52.24 degrees. All right. Now, what about the value of r? R is just going to be square root of a squared. So that's square root of 6 squared plus b squared, which is square root of 10 whole squared. That gives us square root of 6 plus 10, which turns out to be 4. The value of r is 4. Okay, so you just have to find these two values. Now let's write in that form. R is 4 into cos of theta minus alpha. Alpha is 52.24. Remember, this value is going to be placed in place, going to be written in place of alpha here, not theta. Theta remains as it is. In place of alpha, you write 52.24. This is the form that we had to convert it to. That's done. Let's look at the second part of this now. Part 2. Now it says, hence, in each of the following cases, find the smallest positive angle theta which satisfies this equation or this equation. So we have two parts. So we have to solve these two equations and find the smallest positive angle theta. Now, see, normally we are given intervals for the angles, but we're not given any interval here. What we're looking for is the smallest positive angle. Now, since the angle is supposed to be positive, we at least have this idea that theta should be greater than 0. And then for theta greater than 0, whatever is the first value that we get, that is going to be our answer. Okay, so that's what we're looking for. So theta should be positive. That means theta should be greater than 0. That's what we understand from this, right? But then greater than 0, we would be looking for the very first value that we get. Okay, very first value that we get, that's greater than 0, that's going to be our answer. Okay. Now let's look at the first equation. Part 2a. What do we have in the first equation? The first equation says square root of 6 into cos theta plus square root of 10 into sine theta. That equals minus 4. This is equal to minus 4. This is an equation that we need to solve now. Remember, theta is greater than 0, and we want the smallest value. Otherwise, there are going to be infinitely many answers if this was the range, because you could just keep going on in cycles. You would have infinitely many answers. We're just looking for the smallest answer on the positive side of theta. All right. Now, how do we solve this? In the first part, what we've done is we've converted this whole thing to r cos theta minus alpha, and that turned out to be 4 cos of theta minus 52.24 degrees. That equals minus 4. This is what we have done in the first part. We have converted this whole thing to a form like this. Now, let's take 4 to the other side. If we do that, it becomes cos of theta minus 52.24, and that equals minus 1. And now we could use a substitution. We could say, let this whole thing be another variable. You could say a or any other letter, doesn't matter. So you have a equal to theta minus 52.24. And now the equation converts to something like this. Cos of a is equal to minus 1. That's the equation that you need to solve now. But remember, when you convert to another variable, you also need to figure out what the corresponding interval for that variable is. Now, if theta was greater than 0, what does it mean for A? Input 0 in this equation, A equals theta minus 52.24. What's the corresponding value for A? 0 minus 52.24. That gives us minus 52.24. So if theta is greater than 0, A should be greater than minus 52.24. So that's the interval that we're going to be looking at for the values of A. All right. Now, cos of A equals minus 1. Remember how we used to solve such equations? If you try to find out the basic angle for this, you would actually figure out it's cos alpha equals 1. Alpha would turn out to be 0 in this case. Right? Alpha in this case just turns out to be 0. Now, 0 angle does not fall in any of the quadrants, right? 0 does not fall in any quadrant. So you can't use the quadrant method for this. You either use the graph of the cos function. Remember what it looks like? This is the shape of the graph. So you know where minus 1 comes in that graph. So you can't use the quadrant method for this. So this is how the shape of the graph looks like. It starts from 1, then reaches 0, then minus 1, and then comes back to 0, and then 1 again. When is the value equal to minus 1? It's in the middle here. So it started from 0 on the x-axis. And then at 90, it's 0. Sorry. So it started from, so x-axis is going to be here like this. It started from 0 here, then 90. At 180, you get a value of minus 1. So either you just write it using the graph. You could say A equals minus 180 here. You can just remember that in your head, that the graph looks like this. So not minus 180, sorry. A equals 180. You know that at 180, the value of cos is going to be minus 1. Or if you don't remember the graph, what we do in such situations is we just try multiples of 90 degrees, right? Because this problem is basically going to come when you are lying on one of these axes. You're either here or here. In these cases, the quadrant method does not work. All right. What are these angles? These are angles 0, 90, 180, 270, and then 360, and then you go around in circles like this. What's common in all of these values? They're all multiples of 90 or 0. So what you could do in such situations is you could just try. So if you don't remember the graph, so that's the easiest. If you remember the graph, you would say that A is 180. But if you don't remember the graphs, what you do is you just try all multiples of 90 in the given interval. Try all multiples of 90 and see which ones of them work. Now, what's the first multiple of 90 in this interval, including 0? So you also have to consider 0. The first one is 0. Let's try that. If A was equal to 0, cos of 0 would be equal to 1. And that does not satisfy the equation. We need the one that gives us minus 1. We could try A equals 90. That gives us cos 90, which is 0. That also does not satisfy the equation. We try A equals 180. Cos 180 equals minus 1. And that does satisfy the equation. Now, since we were looking for the first possible answer, we say A is equal to 180 degrees. So this is another way of thinking about this. Again, you do this in paper 1 generally. If the quadrant method does not work, that is going to be when the basic angle is either 0 or 90, then the quadrant method is not going to work because the angle would lie on one of the axes. In those cases, all you have to do is just try multiples of 90, including 0 in the given interval. and see if they satisfy or not. So greater than minus 52.24, the first angle that you have is 0. Try 0. Does that satisfy the equation? It does not. Does 90 satisfy this equation? It does not. Does 180 satisfy? Yes, cos of 180 gives us -1, so that satisfies the equation. So the value of A that we have here is 180. That's the only answer that we're looking for. Now, since A is 180, we put the substitution back. A was theta minus 52.24. We say theta minus 52.24. That equals 180. So the value of theta that we get from this is 232.24 degrees. That's the value of theta that we get as the answer from this. Is that all right? That's B part 1. 2 part A, sorry. Okay. Let's look at the next part. Now it says solve this equation. Now it's slightly different from the previous one. Instead of theta, we now have half theta. Let's think about this. Again, I'm going to write down this equation here first. The equation is square root of 6 into cos of half theta plus square root of 10 into sine of half theta, and that equals 3. This is the equation. Again, we're looking for the smallest positive angle theta. So theta is greater than 0. That is what we know. We would be looking for the smallest possible value of theta in that interval. Now again, how do we start? We have done something in the first part, and that is we have converted this expression, square root of 6 into cos theta plus square root of 10 into sine theta. We have converted this to 4 cos of theta minus 52.24. This is what we have done in the first part. All right. Now, how are these two similar? Instead of theta here, we have half theta. Right? Instead of theta, we have half theta. So what we do is on the right side as well, when we convert it to that form, instead of using theta, we put half theta. So this is going to be converted to, this could be written as 4 into cos of half theta minus 52.24 degrees. And on the other side, you have 3. So now you have this equation. This is the equation that you need to solve. All right. Now, again, how do we start? We could take 4 to the other side first, or we could just do the substitution first right away. So any of them works. Let's say you replace it by another letter. First of all, you say A equals, so use the substitution, A equals half theta minus 52.24 degrees. That's the substitution that you use. So this equation converts to 4 cos of A equal to 3 now. This is the equation that you need to solve. All right. But again, you have to adjust the corresponding interval as well. If theta is greater than 0, what about A? Just input 0 in this equation in place of theta. If you input theta equal to 0 here, you get 0 minus 52.24. Again, A has to be greater than minus 52.24 degrees. That's the interval that you're given for A. All right. So you have to keep this in mind when you're looking at quadrants later. Now, how do we solve this equation? 4 cos A equals 3. Let's find the basic angle. We say this is 4 cos alpha equal to 3. Cos alpha equals 3 over 4. Let's find the basic angle. Again, it's in degrees, so we need to find the angle in degrees, the basic angle. Let's figure that out. Cos inverse of 3/4. What do we get from this? 41.4 degrees. 41.41 degrees. Okay, so we want more accuracy so that our final answer turns out to be accurate. 41.41 degrees. This is the value of alpha. Now we think of quadrants. This is how quadrants look like. Cos is positive. Which quadrant could that be? It could be the first quadrant or the fourth quadrant again. You could have a basic angle here that is 41.41, or you could have a basic angle here, which is 41.41. Now, A is greater than negative 52.24. You could have an angle in the first quadrant that could be 41.41 degrees. But notice, what are we looking for? We are looking for the smallest angle in the interval. Smallest angle in the interval. Now, theta was supposed to be positive, but A has this interval that A is greater than minus 52.24. Now, if you think about it, this angle minus 41.41, this actually does fall in the interval. So that's the smallest value that we should be using here. That is minus 41.41 degrees. This is the smallest value of A that we have in this interval. So this is what we should be using since we're looking for the smallest angle. All right, 0.24. So that's the value of A that we use here. Now, what was A? A was half theta minus 52.24. Let's put that back. We have half theta minus 52.24. That equals minus 41.41. And now we find the value of theta from this and see what that turns out to be. So it becomes theta equal to 52.24 minus 41.41, and goes to the other side. And this whole thing gets multiplied by 2. And that is going to give us the value of theta. Let's see what that turns out to be. So the value of theta that we get is 21.7. This is the smallest positive value of theta that we have. If we had used 41.41, that would have also given us a value of theta, but that would have been bigger than 21.7, and that would not be the smallest value of theta then in that given interval. Is that okay? So that was the second part here. You should have done this in paper 1, how to solve these equations. But if you don't remember that, this is how we approach these equations. Make sense? Any problem with this? Any questions? All right, so if you understand this, we will do a couple of more practice questions tomorrow and also talk about graphs of reciprocal trigonometric functions, graphs of secant, cosecant, and cotangent. We will do that tomorrow, and then we will wrap this topic up. On Thursday, we start differentiation, inshallah.